you really quickly just where we were on this? You were looking at the stars. You looked at star A and you lined it up with the lines. So just to remind you of where we were and how to do this. So the lines that you see for star A are the absorption lines that are given off when you look at that spectrum. So again, just to make it really make sense to you, you take the fancy glasses or very similar things that actually have numbers that can tell you exactly what the wavelengths are, and you can take a picture of what that star looks like. Okay? And you'll see lines, just like we did with the hydrogen tube, or with the helium tube, or with the neon tube. Please stop. Thank you. Okay? And then you can compare those to our known elements. And by comparing it to our known elements and the fingerprints for those elements, you can determine what was in or what is in each star. So I think yesterday you made it through at least star A. Is that correct?
Yes.
Okay. So would you tell me, so that I can write it down too, what elements did you find? Haley, what'd you find?
I found helium, iron, and calcium.
Helium. Oops, and I'll write them all out all the way. You saw iron, and you said calcium as well?
Yeah.
Ladies and gentlemen, do you agree with her? You didn't see calcium?
No, I did not see that.
So, when I did it before, I saw helium, I saw iron, and the other one that I saw was not calcium. Did anybody else see something else? Sodium? Yeah, that's what I saw as well. So, when you look at this again, because I'm going to give it to you in just a second, take a look and see if you can see those three. When I hand these out to you today, I'm going to give you both the slider, the original star A. Please listen. Shh. Please listen. And then I'm also going to give you stars B, C, and D. So what you do with the little tiny piece here is that you're going to take this and you're going to line it up. You can make sure it's lined up because that dark band at the very bottom is lined up here. Okay? And then you can look for the other elements. I will warn you that they are all very similar, but they are not exactly the same. I'm going to give you a few minutes to work on these. I want everybody to make sure that you have the opportunity to look at this because, fair warning, spoiler alert, on Friday, on your quiz, you will have to do this kind of thing. So I'm going to give you a star and I'm going to give you a couple of elements and I'm going to say, is that element in the star? So if you are not confident about what you're doing today, you need to seek help. You need to talk to your table mates or you need to come talk to me so that you understand how to do this because you're not going to have your partners to help you. Do you understand what I'm saying? Okay. So why don't you send one person from your table up to get things and then we will continue on. It's kind of hard to see. So the ones that I give you for the quiz will be lined up just right. So you'll be able to see. So I just want to remind us what we're doing so that when you're, studying for a quiz that's going to happen on Friday, you have this written down. So you want to make sure that all of the lines, So you're writing this down too, right? All of the lines of an element line up with lines in the star. Do you? Did you write that down already?
Yeah.
Okay, good. Well, I'm glad you did. I do have it. I have it written down too. This is a different copy than the one we had before, I think. So if you don't have that written down, if you want to write it down again because you want to make sure it's right, you've got it. So that's okay, except, and maybe I wasn't thinking it all the way through. If there are lines in the star that don't match with an element, that's okay. Does that make sense? Because stars have more than one element in them. So all of the lines of an element, yes, all the lines of an element have to line up with lines in the star. Okay. I'm just answering. Yes. No, but I'm telling you it is. Yeah.
She was asking if it was the 10th.
The 10th?
Yeah. We said yeah.
Yeah, and I did too.
Yeah, but they were laughing. I didn't know what.
Oh, that's a fair question. It's always right here too.
Oh, I can't see that.
Okay, but I'm just letting you know. It's there. You can always get up and look at it. Helium, iron, and sodium. What'd you say for B? There was sodium.
Was there hydrogen in it too?
I saw hydrogen.
That's all I saw.
I had a helium with a question mark there.
You did?
So if you had helium, cool. If you didn't, that's okay too. Okay. I again, the ones that you'll see in a quiz or a test should be very clear. Again, all of the lines of the element have to line up with the lines of the star, and it's not going to be shifted, so you'll actually be able to see it pretty easily. What did you say for C? What did you guys have in star C? Iron, hydrogen, and sodium are the ones that I had written down. Yep. And then how about for D? Hydrogen. I didn't see any sodium, but there was a question mark by that one for me. I saw some helium in there too, but I may have missed that. Did we all see hydrogen at least though? Yeah. Okay. I don't want to belabor the point.
Iron was in there?
I did not see any iron in that one. That was a question mark one. Yeah. So this one was kind of hard to read, I think, is really the moral of the story. But the process, are you getting the process? Okay. Process is the important piece. All right. Would you please put all of your little star pieces, so that's C, D, and E, or excuse me, B, C, and D, in the baggie. Zip up the baggie. Have somebody bring that up to the bin that's right up here on the table. Everybody else is going to flip over that sheet. You hopefully have some answers written down, but we're going to take some time to go through that sheet to understand it.
Yeah, I was super.
Yeah, that's why we're going to talk it through. Yep, so don't whine about it. We're just going to suck it up. Hop up. Quick.
Not gonna lie, I looked at the sheet.
All right. Ladies and gentlemen, here we go.
Get up.
I say no.
Get up.
Did you flip your sheet over? Flip it over. Here we go. There's a lot of really important information here, ladies and gentlemen. I think that sometimes my friends that know how to play school just think that worksheets are just worksheets and they're not really anything. This one, there's a lot of information. You need to know this information. Take your ear out. Thank you. So I want you to listen. I want you to pay attention. I want you to work with me on this. Okay? The first thing that I want you to highlight or circle or put stars by or whatever it is for you, okay, is the phrase Hertzsprung-Russell diagram. You need to be familiar with that. Hertzsprung-Russell diagram. It's a weird name, but friends, it's just two names of two scientists. Okay, I'm lazy, so instead of calling it the Hertzsprung-Russell diagram every time, I'm just going to call it an HR diagram. Okay, HR, H stands for Hertzsprung, R stands for? Oh, that's good, right? So Hertzsprung and Russell, who were they? They were two scientists, two astronomers that lived on opposite sides of the planet. One of them, Hertzsprung, I think is Dutch, if I'm remembering correctly. Russell was from the U.S., okay? They both had tables and tables and tables of information about stars. Looking at a table doesn't tell you a lot, like it's hard to see patterns. There are some like really fancy people that can see patterns in numbers, but a lot of us can't. And so both of them, separate from each other, not talking to one another, not even knowing that each other existed, they were like, I'm going to graph this data. Now, here's the funny thing. I may change the details of the story a little bit because I don't have them all exactly memorized, but this is basically the long and short of the story. One of them had information about temperatures of stars, okay? And also had information about luminosity of stars. And so that person, I don't remember which one it was, we'll say it's Hertzsprung, he took that information, he's like, I'm going to graph this. Because when I'm looking at a chart of numbers, it doesn't mean anything to me. So let me put it on a graph, maybe something interesting will come of it. So he took the temperatures and he took the luminosities and he graphed them and he got this funny looking picture with this whole set that kind of goes down the middle. You see that? And then some cluster here and one like there and one right there. So we got a few different things. At about the same time in history, this is like less than 100 years ago, I think it's something like on the order of about 50 years ago, there was also another scientist in the U.S. who had a big table of data about stars. But the data that he had about stars had to do with the magnitudes, what's that? We'll talk about it in a minute, And the spectral class, what's that? We'll talk about it in a minute. But he had absolute magnitudes and spectral class of stars. And he's like, I can't see anything in this data. Let me put it in a graph. And so we graphed it, and he got this really interesting thing with this band that goes down this way, and a little closer here, and some over here, and some over here. And something happened such that maybe they were at the same meeting, or they had friends that knew each other, or something like that. And one of them was like, look, I made this really cool chart. I'm going to be famous. And another was like, look, I made this really cool chart. I'm going to be famous. And then somebody was like, wait a second, you guys. It's the same chart. Do you see that? It's the same chart with the same band that goes down the middle, and then one here, and then one here, and then one here. They did the same thing, totally separate from each other, with different information, and they got the same picture. It was amazing that they did that they thought to do it that way, so much so that we now teach ninth graders all over the world about this thing, right? So it's a big deal. We can get a lot of information from it, and they got it named after them. Both of them did it, so both of them have their names on it. Okay? Eventually, yeah. Eventually they did. So it's really important that we know how those things put together. Please, I'm going to ask you one more time to put that away. Thank you so very much. So now I want to look at this chart because the chart is important. There's a lot of detail in that chart that I want to make sure that you see. So question one, or it's not really a question, it's more of like a, hey, look at this, talks about this funny band that goes from the top left to the bottom right. That band is called the what? The main sequence. So on your graph, you probably haven't labeled this already unless you're like really active in this way. Go ahead and label this the main sequence. I don't remember the details. I'm not like a numbers person in terms of like having these things all memorized, but it is something like 80 or 90% of all of the stars that we have data on. And we have data on a lot of stars. Something like 80 or 90% of all stars are in the main sequence. Almost all of the stars we see in the sky are in the main sequence. They live in that band on the HR diagram. Okay? Does somebody have a question?
Do we know what the stars in the top left corner do?
We do know what do you mean?
Like do you know what the name is?
Up here in the top left corner?
Yeah.
They're just part of the main sequence.
No, like the B, C, D things.
These guys?
No, I'm talking about like the absolute top left corner.
They're really
small.
I think are you asking why it's not in the circle? I think just because the person that put the circle on there didn't include it. I think anything in this band here, like these guys down here too, I think all like that, if I were going to draw the circle, I'd include all of those, right? Everything that kind of lives in this line is the main sequence. Why do you think it's called the main sequence? I just gave you the answer. What is it? Most of them are in that section. So if you didn't write that down before, write it down now. Most. And again, I'll look it up because I can't remember the number, but it's something like more than 80% of all stars are in the main sequence. So that phrase is something I want to make sure that you're aware of, that you've seen, that you understand. Okay? Question 3 says our sun has a luminosity of 1. Okay, a luminosity of 1 and is a G-type main sequence star. Okay, so this is one of those times, ladies and gentlemen, where we're just going to smile and nod and deal with what we see. Okay, I can't remember if I told you earlier in the year what my job was prior to coming to Liberty High School. Did I tell you what I did before I came to Liberty High School?
No.
Okay, so was that? I did. I worked at a different school before I moved to Iowa City. I worked at a different school for about 10 years. And then we moved to Iowa City, and I did not teach. I took a year off from teaching because there weren't any science jobs. And I actually had a job working for ACT. So there is a high probability that when you're a junior in high school and you take the ACT science portion of the test, that the test that you take has at least one passage and questions that were written by me. And I don't mean that in a braggy sort of way, like, ooh, I'm so cool. I don't mean that. The reason I'm telling you that is because there are a lot of times when I'm going to focus on something and you're like, I don't have any idea what this means. Why are we spending time with this? And the number one reason, the whole reason I do this is because I want you to be successful on things like the ACT. And it's not just a one-time deal with the ACT. Friends, the ACT science test does not really require any knowledge of science. What? It doesn't require any knowledge of science content. It requires knowledge of how to read a graph, to follow and find trends. It's going to be awesome, right? It is not hard. What you need to do is find trends. You need to be able to make observations. And that's what I'm helping you find. So without understanding anything about luminosity or spectral class, you should be able to do question 3. You're going to find the axis that's labeled luminosity. Put your finger on that axis labeled luminosity. And find on that axis labeled luminosity where the 1 is. Everybody find that. Put your finger on it. Okay? And then you're going to find the axis that's labeled something that says a G. Find the thing that says a G. Okay? Right down here in spectral class. Find the 1. Figure out where they go. They're just kind of up to the right of the A, and you're going to put an X there. Put an X there. It's in the main sequence. Oops, I guess it's a little bit further over. Sorry. Got a little excited. So there's G. It's like right there. That X is where our sun is. If you haven't labeled it yet, go ahead and do that. Our sun definitely lives in the main sequence. Okay? Our sun, the thing that we rely on for life and everything, is just a regular old star. Nothing really wild and crazy and amazing about it when it all comes down to it. Okay? Life is okay so far? Okay. So we still don't know what luminosity is or spectral class or any of that business, but we can do that problem, and you can do something like that on the ACT. No problem. You got this. Question 4 says, what information can we learn about a star by looking at the Hertzsprung-Russell diagram? So let's say that I'm going to look at, I don't know, let's pick a star. Maybe this one right here. I'm just picking a random star. If I pick this star, what information can you tell me about it? Go, Haley. What do you know?
Probably the temperature.
Yep.
That's fair. And then the magnitude.
Yep.
And the thing on the side.
The other two, the other thing on the side, you got magnitude and you've got luminosity. And I guess something like spectral class, huh? For sure. Okay. So here's kind of a funny thing. Usually when we look at a graph, we only have 2 axes that are labeled, right? You have the x-axis that's labeled and the y-axis labeled, and that's your set. How many things are labeled on this one? How many axes are labeled?
All 4.
All 4. That's weird. That's kind of weird. But here's the funny thing. This axis here and this axis here, because they're in the same plane, the 2 ones that are vertical, they're just 2 different measurements of the same thing. Okay? It's kind of like if I had half of you measure all of the rectangles in the room and do length and width in centimeters, and I had half of you measure all of the rectangles in the room with length and width measured in inches. Are you with me there? If we graphed all the rectangles in the room with width and length, and you had centimeters and centimeters, you had inches and inches, we could graph all of the same rectangles because we can scale inches and centimeters together. Are you with me there? Do you understand what I'm saying? 2.54 centimeters in an inch or something like that. So this thing over here, luminosity, and this thing over here, absolute magnitude, mean the same thing. They both are quantifying how bright the object is. So magnitude and luminosity are both quantifying how bright the object is. Okay? In a little bit of different ways they are, but it's the same thing. Temperature and spectral class, again, are the same deal. Temperature, we're not literally putting a thermometer into the sun or into a star. It would be too darn hot to get there. And number 2, it would take us a really long time. So how do we tell the temperature? Anybody know? What's that? I could not hear what you said. By seeing what's in it. So part of that's true, absolutely. Looking to see what elements are there. And how do we find out what elements are there? What do we look at? The what? The light, the spectrum. We look at what's coming from it, right? We look at the color of it. Yeah, to find out the temperature of a star or the spectral class, we're really just looking at the color of the star, okay? And we're trying to figure out how hot it is. Okay. So we're taking the temperatures of the stars. We're trying to figure out how bright they are, and those two pieces of information give us everything on this graph. Many of you have already answered these questions, but some of you haven't. Right now, with your table mates, I want you to work on number 5, number 6, and number 7 together. So if you've all got it, then just compare your answers. If some of you don't have it, take a minute to help each other out, figure out the answers. Have a conversation right now. Go. All right, let's hop in. Here we go. So question 5, Isaiah's got this one for us. Main sequence stars form a band that range in temperature. Just chill out. Let me help you out. Shh. Range in temperature, color, magnitude, and luminosity. White stars. So let's first of all make sure we agree with that because we want to read stuff, right? Main sequence. They range in temperature. They range in spectral class. They range in everything because they go from the top left to the bottom right. They go over this whole area. White stars are located in D. They're right down here. There are just a few of them on this graph. There are a lot of them out in space, but compared to the main sequence, there are not a lot of them. Their highest energy stars, that's good to know. What is their general range in temperature? I'll help you out if you need help. Just got to ask. What's that? 10,000. That's a good area. Yeah. So we're talking about like, if we just kind of look at where these guys are, they're like this. Yeah, does that make sense? Yeah? So let's kind of So 10,000 is absolutely in that range. So good for you. Are all of them exactly 10,000? No, they go a little bit higher and a little bit lower. Maybe 8,000-ish?
Yeah.
And to like 25 or 25,000-ish? Does that sound okay? 8,000-ish to 25,000-ish? Now here's a question. As a scientist, and I know y'all are scientists, in your heart of hearts you are, if you just write these numbers down, this doesn't mean anything to you. We need to know 8,000 to 25,000. What? I don't know. We got to find it out. We got to look. So here's the thing. Again, this is ACT skills, right? I don't know what it's measured in. Let's look at the graph. It says effective temperature, and then the unit is in the parentheses, right? What is this?
Oh.
Yeah. So some of you are like, oh, of course. Some of you are like, I don't know what that is. And again, this is one of those things. You smile and nod and spit it out, right? It says K. So what are we going to write down here? K. And then the scientific content person that I am is going to say, okay, so if you don't know what that is, let me tell you. So when you measure the temperature of your, like if you are trying to figure out if you have a fever, you put the thermometer in your mouth and it beep beeps, and then you tell it, you look at it, and it says that you have a temperature of 98.9 what? Degrees Fahrenheit, right? Degrees Fahrenheit. And that's because you're in the United States or in the United Kingdom, and so we measure things in degrees Fahrenheit. Life is fine. If you go anywhere else in the world and you stick your thermometer in your mouth or, the forehead, because now they do all the forehead one, right? And they measure your temperature. If you told them that you were 98 degrees, okay, so let me just think about this for a second. Does anybody know what water boiling is in Celsius scale? 100. If you tell somebody that your temperature is 98.9, they're going to say, oh my gosh, like you should be dead. You should not be alive, because they're thinking in what scale? Celsius. Yeah, they're talking about degrees Celsius, right? So degrees Celsius, you would be dead and you would be almost boiling. Ouch, that'd be bad. Okay, so these are just different scales. Okay? Everywhere else in the world, Celsius. In the US and in some parts of Great Britain, Fahrenheit. In science, we often will use degrees Celsius, but often also we'll use this thing called Kelvin. Okay? And it is the absolute temperature scale. So this is information for you to know if you didn't know this already. Here we go. This is the absolute temperature scale. Okay? It is not, so this is me trying to look out for you so that other people don't laugh at you. It is not degrees Kelvin. They will laugh at you. They might not laugh at you outside, but they will laugh at you inside, and they'll be like, oh my gosh, this person, what are they talking about? So it is 8,000 to 25,000 Kelvin. Not degrees Kelvin, just Kelvin.
Is that named after somebody?
It is.
Yeah.
Lord Kelvin? Yeah. He did a lot of stuff with temperature. Big surprise, right? Also do a lot of stuff with other things too, but that's the thing that he got his name attached to in this case. Yeah. Do you remember earlier in the year when I was telling you that you glow?
Yeah.
Do you remember that? And I told you not only do stars glow and not only do you glow, but everything glows?
Yeah.
And I said that there's only one kind of stuff that doesn't glow. Do you remember what it was? Not you. Not you. The only thing. Did you just say that? There you go. I just wanted to
I say not to say it, so I just.
Gotcha. Yeah.
No.
The only things that don't glow, that do not radiate electromagnetic waves, are things that are at 0 Kelvin. Okay? So everything radiates unless you get down to 0 Kelvin. 0 Kelvin is what we call absolute zero. And in fact, we've never been able to measure something at absolute zero. There's a whole reason for that. Take chemistry or take physics and we'll explain it to you. But now you know a little more science for today. So there you go. You're welcome. All right. Question? Yes, what's up? Are you sure?
No, it's just fine.
About what?
No.
Do you want to tell me an answer for number 6? Is that what your enthusiasm was about? Because I don't want to squash that enthusiasm. Mariana's going to tell us the answer for question number 6. Red giants are located in section B. So let's look at the picture because I want to see. I want to know. So here are the red giants. So if you have not yet labeled that on your graph, let's do it. Here are the red giants. Did you label it on your graph? If you didn't, do it now. You got the main sequence. You got the red giants here. The white stars down here. Main sequence, white stars, the red giants. Tell me about the temperature of the red giants as compared to those of the white stars.
Red giants are a lot colder than the red stars, about half of the time.
Yeah. So the red giants are much cooler than the white stars. Okay? Mariana, about how hot are the red giants?
They're about 10,000.
The red giants? So we're looking right here.
Oh, sorry, I was like.
That's okay. No sweat.
About like 3,000.
Yeah, we can say 3,000, 4,000, something like that. Yeah.
I would say 6,000.
6,000 is here. Yeah. I mean, I was just looking for like a kind of just an estimate. So somewhere between 6,000 and 3,000, yeah?
Okay,
Yeah, but I just wanted to get a sense of what that was. So they're about, let's just say about 4,000 Kelvin. That's pretty nice and cool, right? Just to give you a sense, because I think it's important to have this idea. How much is 4,000 Kelvin in Fahrenheit? Just to give you a sense. 6,740 degrees.
Oh my god.
That's warm. Right, I know, 0.33, right? Yeah. Little fusion many sig figs there. But anyway, yes. So we're talking on the order of like 6,000 degrees. So it's a lot cooler,
But it's so hot.
but it's still really hot. So don't complain about August in Iowa, right? It's still really, really hot. Let's do question number 7. Supergiants located at section C are much more massive than red giants. They're even bigger. They're humongous. So let's label those the supergiants. The supergiants are much more massive. And then it says, what is their luminosity? So we're going to write that down, except somebody already did. So let me ask, I don't know, who am I going to ask? Duranda, what did you guys come up with for the luminosity of the supergiants? 10 to the fourth. Yeah. So then we're going to ask the question again, and it might be hard to see in the way that this got copied. The units for the 10 to the fourth, because what does 10 to the fourth mean? I don't know. So if you look at this, I'm going to write it down because it's hard to see on your graph. It's the luminosity of the star divided by the luminosity of the sun. So really, what does that mean? It's a ratio. I'm going to tell you right now. So you're going to write this down. 10 to the fourth just means that there are 4 zeros. Okay? So it's 10,000 times brighter than our sun. Woo! Have a great day, you guys. Bring this back tomorrow. We'll finish it up. Thank you.